So, integrating the new level editor features on the turn-based game was pretty much effortless, since all they had to do was what happens after and before we actually create the level. Okay, and of course I had to create a new level. Now that we have ways to place walls, of course we need to update our pathfinding. So what we're going to do, I'm going to split it up into two parts. We're only going to focus on this part into two-dimensional pathfinding, and on another part we will see the pathfinding on multiple floors, and then we will take care of a few problems. So at this point we do not care about the double movement or blue movements and all this stuff, if we can reach them or not. Okay, so if I select this guy, he cannot go into any of these nodes since there is walls around him. And we're also going to see examples like this, that the wall over here is has a window, so it takes the window as a place so that he can actually pass from inside the window, like it is in XCOM. And of course doors, okay, which in this case they work kind of similar like windows, but you will see that when I want to pass from inside the window, you will see that the interpolation is not straight, but it goes a bit up, and then it moves on your regular path. Now of course we have seen a few different interpolation examples, so we can do a lot of stuff over here and of course play an animation, but as far as this video is concerned, we're going to only make him interpolate up and then continue on the next node and continue so on. Okay, so let's start with the scripts. Let's clear this. So we first need to, since we have a new grid and a new way and a new objects on our grid we were using, we need to see the new grid and also some other stuff we have to change over here. So I have my database, my load database and all that, and I also have my session master, and I need to get rid of the stuff that uncomment the stuff we had on the level editor, since over here we actually have those functions, which are the functions we have seen before. Now, okay, the whole logic and the whole order is similar. On start, we get the references and we start loading the database. After we have loaded the database, which is loading all the asset bundles, checking for icons and all that, then it's called this function, the load database, and it returns to continue loading the level. We create a base level, and if it's the level editor, we start. If it's not the level editor, we start our level. We load the level. Of course, we load the reference first. We load the level. Right now, we'll just use this one. Later on, we will see a lot of cases for this. We load the scene. We initialize the level. Okay, if it's the level editor, we load the level editor. Everything else stays the same as we have done in the previous videos for the turn-based game. And we need to go on our grid and start loading, updating references for a level. Let me save the Pathfinder. So we need to go on the grid base of the grid master. Now let's take it from the start basically, so since there's kind of few changes. Okay, when we initialize the grid, we start loading the grid. which is in our case, I think it stays the same. Yeah. Okay, the way we were creating the needs before. But if the node is walkable or not, we're going to add it over here and say if the node is walkable or not is controlled by if the node we have on the level editor has a placed object or not. Okay, so if the node from the level editor has a placed object, so we have placed something on it, then this will not be walkable. We also need to do a few changes on over here. So if we are on if the node we have on the level editor is an air node, we need to change the type, of course, for the new node. We need to change the tile material with our function, which just goes and closes the tile renderer. We also need to change to close the tile renderer for the ground. Okay, from the node object which is stored inside the node reference, and of course it's not walkable. Similarly, if it's a ground, then we also need to do what I've said before, and in any case we pretty much want to change the node reference to be the tile material for the node reference to be none, and that is as far as the indicator is concerned. The indicator, by indicator I mean the red parts under a node that is not walkable or it's occupied, and the blue parts and the yellow parts for the other nodes, which I hope you can see. And since I want this to be closed, and yeah, pretty much I want this one to be also closed on the prefab. So as far as the tile render indicator, I'm opening it over here. Okay, just write it like this. I have this way since on my prefab I want this closed, because when I run the level editor and not the actual level, I will having this mess in front of the on top of the other quad I have over here, on top of the other mesh renderer, so I wouldn't be able to see what I've actually painted underneath on my node, basically. Now, okay, the changes we have to do on the actual loading grid. Now we need to load the wall grid. The wall grid is our nodes that connect, and when two nodes connect, there's going to be a wall over there, and that wall can be a different type, and it can be a wall that has a window, it can be a door, and it can also be a wall. So for every wall grid list we have, which we're going to take it as it is our floors, we go and do 2 for loops for the x and the z axis. We find the actual wall node by using on our wall grid holder, using the get node, and then of course if it's null we skip this part, this entry, and I think this is for Z too, so yeah, this probably will not actually work, but I think this one wouldn't even, yeah, this one doesn't return null, so let's get rid of this. So if it has connections attached, the current node has the current wall node has any connections attached, then we go and for each connections we have seen on our node, then we start we want to get that connection, we store the connection over here, it's gone. Yep, I had an if statement, so I do not read twice the connections, but it didn't work exactly as I wanted, so I just comment out this. You might not even need this to be in an if statement anyway. And yeah, on connection node I actually went and added this boolean, but yeah, it's not necessary since I pretty much do not even use it over here. So we have our two connections, our two nodes, and we need to find a way to connect with the wall with a tile grid. And since every node sits on the corners, every wall node sits on the corners of the tile grid, okay, you can understand that there is a problem because we cannot actually, if we do not know what nodes from the tile node the wall node is going to affect. So what we do know, we have two wall nodes to have a wall. Okay, so that means a connection. So that means a direction or a side from the tile node. So how do we find which side the wall is blocking on the tile grid? We store the first position of the first wall node, and we stored the second position of the wall node. And the second position, we take what node this node is actually connected to, okay, to actually have a wall in it. And here's what we're doing. We find the actual wall position we want to place. To find it, we take the first position, we find the direction, and we normalize it between position 2 and position 1. So we find the direction between the two nodes, and we multiply that by the distance subdivided by 2, and that gives us the half distance. So it gives us a point between node A and node B. We have our target positions over here, since every wall must affect two sides. Okay, so not just two sides of two different tile nodes. So we have our tile nodes over here, target node 1, target 2, so we need to go and actually find. We have a switch, and over here we have our wall object direction. Here's where it's going to come into play once again. We can place walls into two directions. Either they will be looking north and south, or they will be looking west and east. Now, if the wall, my north is over here, okay, so our walls can have two directions, which is either they look this way or they look this way. Now, if they look north to south, that means we need to find a direction, okay, north to south. We need to find the node that sits over here and the node that sits over here. Similarly, if they're looking from west to east, we need to find the wall over here and the wall over here. To do this, we get we get the target position. Well, the target position we want to have will be the wall position we have over here. We find it, so the middle point between 2 points, and we either add vector 3 dot right or minus dot right. So we find this way we find the positions for the two nodes. Of course, these are positions, wall positions, so we need to find the actual node, and we do that by using the function node from wall position. For both of these nodes, we can check now, and we pretty much have to check if the target node is equals with the target node 2. Okay, if these two are equal, then we do not need the target node 2. And we update path and cover status, which is a new function. We have to pass target node, the connection, and the desired direction. Okay, similarly with this, we pass target node 2, and the desired direction is either west or east. Now here is the catch. Target node, target position 2 stands for the target node that comes over here. Okay, this is the west, this is the east, and I think, yeah, this north is south, so let's see it as north south. North south. Now the target position 1 is dot right. So if this is the middle point, the target position plus will be plus dot right will be this node. Now I do not want to affect the west side, the east side of this node, even though this node sits on the east of this connection. Okay, I want to affect the west connection. So whenever I am affecting target node 1, it's going to be mean this this side, but I want to affect the side that looks towards my connection. So in this case it will be the west side, in this case it will be the east side. Okay, so the target direction is kind of opposite of what we are looking over here. Okay, so do not confuse this, otherwise you're just going to have to switch it up. Similarly to the west and east, but since our walls are looking to the west and to the east, we are using vector 3 dot forward and minus dot forward. Okay, everything else is the same. On the north node we are affecting the south direction. On the other node, on the south node, we are affecting the north direction. So let's see the update path and cover function. Let's close this. Let's come over here, takes a node, a connection node, and the desired direction. If the node is not null, otherwise doesn't do anything, then it takes for the connection the wall type that has that the wall object has of that connection. If it's a wall, then you go and set the direction on your node, and I think we have, yeah, we do not have this function. We need to find it over here to create it, and I've actually updated a few stuff inside our tile nodes. Okay, this node is from the grid master. What we have a new class that stores path directions. It pretty much takes a direction and a direction status. The direction status we can have will be either be walkable, partial, or blocked. It's pretty much the same as the cover options we have. Now we have a list of this, since every node can have and will have 4 directions: north, south, east, north, south, east, west. And we can also have a constructor over here which goes and pretty much populates this list, and it sets the new direction. Directions are the same ones we had on our covers, NSWE. Okay, north, south, west, east. We set a new direction and we make them walkable. We initialize them as walkable on the status. Okay, and we add it into this list on the constructor. If I want to find a direction, I just pass the direction and search into the list of directions and return the one that is the same. If this returns null, then there's probably a problem, so you need to check that. Set direction finds a direction from over here and changes the status. Now let's go back to our grid, to our actual grid base, and we're over here again. Update path and cover status. As I said, we pass the node, connection, and target direction. We find the current wall type we have, and if it's a wall, we set the direction to and change the direction status to block. We also need to change the cover status, and we pass the same. This is the same function. We have seen this one before. Okay, nothing changed. Pass the target direction and change the cover status to full. If it's a window, direction status will be partial and cover status will also be partial. If it's a door, then direction status is walkable, since doors are pretty much walkable. And there is no cover status, since a door, unless the door of course is closed, but that's another case, then there's no cover status on the actual node that there is the door. Now let's see where we call this function. We call it after we load our grid. We load the wall grid. We pretty much goes and updates function updates the grid we have just loaded. Now just with this, let's see where I have to do a few changes. Let's see some other changes we have to do. So on our wall UI manager, when we were getting the neighboring nodes for our units, where the blue and yellow stuff we had over here, we were basically taking the same distance for the Y2, but we do not want to do that, so we changed this to -1 and to 1. Okay, as a side note pretty much. Now we need to do a few other stuff, and then we can move on into changing the pathfinding. Let's see on our player interactions what we have. And here's a change we actually have to do, because on our player interactions, where we are finding the node from mouse position, we were using recast hit all, and we were taking the first hit we find. Now recast all doesn't work exactly that way. It doesn't sort positions into the array based on distance, so the first one you hit doesn't mean it's the first if it's the closest to you. So what we need to do is sort this sort everything out. So we create a list of nodes, which we start with this, and for every hit we find on arraycast hit, we find the node that corresponds to that wall position based on the actual hit point, if it's not null of course, and the node type is actually ground, it's not there. And then we add on our ground nodes, we add that node, we add it into this list. Now we need to go into this list and find the closest one to the camera, since this is probably the one that is under the mouse. Not probably, pretty much that will be the mouse, under the mouse. We start with the minimum distance of infinity, and then we find a temporary distance between the wall object and the camera, the main camera transfer position. If the temporary distance is lower than the minimal distance, okay, minimal distance will be assigned as the temporary distance, and the return value will be the entry we have on our ground nodes list, and we return that. Okay, another side note. Now let's see. I told what this is. We do not need it. Node references. I made this public, as I write over here. Okay, small changes. It's not something that game changing. Anyway, wall creator, and I don't know why this is. Yeah, the wall direction will be also public, although I do not know where else I use this. Yeah, so forget that. Now, we also forgot to, when we are loading the level on our level save load, a line I forgot to do, okay, is to also update the direction of the newly created wall, okay, and we take the direction from what we have saved inside our wall. And here where's the fun start to happen. Yeah, and here's where we are actually going to do the pathfinding. Now, as far as special connections between walls are concerned, we're going to be taking them that like they cannot. Oops, let's play again. We're going to be taking them as that we cannot approach a node, a special node, and pass from it. We cannot approach it diagonally. So if I move over here, for him to pass and come to this node or to this node, okay, he cannot pass diagonally. Same for doors. If I want to pass from inside the door, I cannot move on diagonal position. Okay, and of course if we have, yeah, that is, and yeah, when we have multiple floors, the same will apply. Diagonal positions will only be able to move on, okay, diagonally when there is no object blocking our path. Or yeah, so to move to this node, all these nodes and the adjacent positions of these nodes must be available to walk to. So with that in mind, let's go to the Pathfinder script, which is one of the very first we've created for this series. And everything we need to change is inside the get neighbor node function. This takes the adjacent positions, which we find from over here, and search top down. If we want to search top down, even though I'm passing through, I've commented out the behavior, and it's not even this behavior we're going to use on the next video, and the current node position. So we start with our return value. We find the first node from the adjacent positions. If that node is not null and is walkable and is a type of ground, so it's actually ground we can walk on, the return value will be assigned as first as the node. But we start into finding the other cases. We also need to check if the direction between the current node and your adjacent position. And we need to do that to know if there is obstacles over here. But if there is a wall, even if it's not directly blocking your path, I don't think I have any examples over here. Okay, even if it's not, yeah, as I said, blocking your path. So if there was a wall over here blocking this side and this side, then he will have to move like this. Okay, he wouldn't be able to move diagonally. If there was an obstacle over here, we have already set it so that it will avoid it, and you will see that I cannot pass over here and move directly over there. And if I move over here and try to move over there, okay, there is no diagonal movement. Of course, since this is a unit, you can't change that, but in this case right now we're not going to focus on that. Okay, if there was a wall covering those two sides, we also wouldn't be able to move there. But if it was covering the other two sides, then we could have gone over there and moved diagonally. And yeah, I should probably have made a level to cover that, but anyway, let's continue. So we need to find two directions. This is a function that returns, it takes an x and a z, but you won't use this passing both of these values to be okay. Yeah, we can pretty much initialize them as 0, but anyway, so you won't call this function passing a value over here and a value over here. And as you see over here, I'm passing just the x and the 0 and just the z and the 0. And that is why if we have different yeah, although yeah, you could do that. No, you couldn't do that, since if you pass two values, it will always return the first one if you put the return over here. So it will always be returning the x, so that's an error. So yeah, do not call this by passing two values too. So you have your return value. Yeah, we'll just initialize it with whatever. And if the x is not 0, so if it's 0, it's going to skip this line. If it's not, it's going to look if the x is lower than 0. That means your node, you're looking towards the east direction of your node. If it's higher than 0, then you're looking towards the west. Same for the z, with north and south, and we return that value. So we find two directions we need to find. Now we're going to check if the original x, the direction basically, the absolute value, is not 0, both for the x and the z. That means we are moving diagonally, and we need to find our neighboring nodes. So the neighboring node 1 will be adding on the x, the original x, the difference basically, and for the neighbor 2 we'll only be adding the z. Now we did a bit of encapsulation. So this is a boolean that takes the current node and your neighbor node. Starts with a return value of true. If the neighbor is null or is not walkable, then it's going to return false. We find the direction the same way we did it before for the current node and the neighbor node. And since this is the x, I'm passing the 0. Now direction x and direction z, it's these two functions which take the one node and the other and subtracts the x of the two node from the from node. Same for direction z, which does that from the z. It's just a bit of encapsulation, okay, it's nothing fancy. So we find the direction for the x and the direction for the z, which pretty much is going to return either north or south or west or east. Now, if the neighbor direction we use, the neighbor, we return the direction we have on the x, and if the status is not walkable, then that means there is a wall, a window, or a door. As I said, doors, windows, walls. In this case, when we are moving diagonally, will be kept in mind like obstacles. So we're not even going to. So we're not using them. Okay, so it's not a valid node. Return false. Same for the z. Okay, if there is a wall, door, or window, then return value will be false, and we return the return value. So it will come over here and it will look if it's a valid node, neighbor 1, or if it's not a valid node, actually, neighbor 1 and neighbor 2 is also, or neighbor 2 is not also a valid node. As I said, to move diagonally we need to have 4 nodes available basically. Okay, so if either of these two neighbor nodes are not valid, then we return value will be null. And we also need to check if the current node and the actual node we're going is a valid node or not on both directions. Okay, so it will look on the X on the north side or south side or west or east to look if there is a wall between directions of these two. So basically the connections you have to look for when you are moving diagonally. Okay, when I want to move like this, I have to check this one node if it has walls over here in this side. For this node I have to check this side. For this node I have to check this side. As we continue, I will have to check for this node these two sides. For this node these two sides. And for my target node I will also have to check for this side and this side. Kinda tricky or kinda confusing, but it's actually very simple. Okay, we just add more variables if a node is valid, if we can actually work on that node or not. Okay, it's nothing different than that. So after we do all this, even if it's diagonally or not, we need to actually check this thing over here. So if the original X is not 0, we need to find the direction for our target nodes and we need to check the status. But since this node is not a special case, so it's not diagonally, we can only check if the status is blocked. Then that means return value can be null. What I can change over here and say if it's not walkable, then this will ignore windows now, but only on the X. Okay, this will work as it was, but if I want this guy to move through this window, he cannot move. Okay, because we only block the X. Of course we do not want that, so we'll keep this one to block. And if I have any other case for direction status, you can do whatever you want pretty much over here. Let's say I can do it over here and either pretty much say that this is not a valid node. Okay, same for the Z as above, and over here we will do later for the nodes that are above us or other floors, because if you want to, you actually have to think a bit what you want to do, since if you want to climb over a wall, for example, how much that will cost to pass, so that your guy actually prefers to move through the window instead of climbing through the wall. And let's say this guy wanted to pass to this node from this node, then you will have to check if this node has something above it, and if the next node has something above it. If it's ground, then that means you can walk on that ground, but it's not your target node, so you actually need to move from you need to find a path from the upper node of this to either something that goes underneath, that goes down and goes over there, or if there's a case that both of these nodes do not have anything on top of them, so the above node is air, then you can make him just climb the wall. Okay, all this stuff are game design stuff. You actually have to think what you want your characters to do there, or you might want them to not be able to climb anything and only move through walls, not through walls, through stairs or ladders and all that. So as far as the pathfinding is concerned, this is what we are going to, this is what we are doing. Now, as you've noticed, there is no distinction between doors or windows. We either take the node, we either say you can pass through this node, or we say you cannot pass from this node. Okay. So, where we handle the actual jumping off from inside windows or not, we handle it actually on where we are interpolating the movement of your player. So we need to go on the unit controller. Let's close the Pathfinder. On the unit controller script, and we actually have to do a few changes. Previously we were using another list which was called the sort path, which take the current path, find directions between its nodes, and if they are similar, okay, it was kinda of only using nodes that you have to use. So if you were moving in a straight line, we're only taking the first and the last node. There was no need to take everything in between. Now we have to do something different, since this is a straight line, but over here and over here there's a special case, or it's not your usual special case anyway. Okay, so we actually have to do a few changes. So instead of using the sort path, I've commented this out, and when you comment this out, it will actually show you everything else everywhere. You have to change this, and we'll be using a new list of just vector 3s. On a later video, since I had a couple more ideas for this, we might change this, so just keep that in mind. Okay, we might change this into another class which stores inside the positions, but also have some more info, because you might not want to have just interpolation like this that goes linear. You might want to have an interpolation like the other interpolation examples we saw, so there is a bit of bounce, or there is smoothness. There is a lot of stuff we can do, and we'll see some stuff. So, wall position path, and as I was saying, of course we need to be clearing the new list instead of the old one. Similarly, over here we had a sort path, so we need to change that to wall position path. Now here's another change I did, which was kind of wrong. I was taking the starting position from the actual node. So instead of that, I'm taking the starting position when we are interpolating our character from the transfer position instead of taking it from the node. So this eliminates a few jumps that our character did, which weren't that nice. Now the target position, we take it directly from the wall position path. This stays the same. And here's where most of the changes were going to be. When we evaluate our path. So we were using a cover direction, we were storing our current direction. For every node we have on our current path, we will find the direction between the next node and the previous node. This goes opposite. Okay. And we were doing this. We were adding them into our previous list, in our previous path, on the sort path basically, when the direction was changing. Now we need to do something more advanced than that, and what we need to do is actually find the direction on as far as the enum is concerned, if it's northwest, east or south. Of course we start with east. Now if it's diagonally, this is already handled by the Pathfinder. Okay, so you basically say, if there is a case that you actually need to be checking your direction, then, and I mean, if you are moving diagonally, you have already checked if there is a wall or something else over there, so there's no need to check over there, or there's no need to check it. And we also know that if there is a special case like windows or doors, then we cannot move diagonally through a window or a wall. So this makes our hands makes it a little bit easier, pretty much. And we can go and say, if the next direction x is not 0, so we're moving on the x, we find the direction. Of course, we need to make it our direction x to an integer, and we also need to find if the direction z is not 0, so we're moving on the z axis. We also need to do the same to find the target direction. There's no case that one will be the one will override the other, since if both of these are not 0, we are moving diagonally, so it will be handled over here. So we have our direction. Now we need a switch to actually see the status of that direction. So we go on the current path, -1, so the next node that we're taking. We return, we find the direction inside the list of directions we have on our node, and we check the status. If it's walkable, do what we were doing before. If it's equals, the directions are equal, the current with the next direction are equal, then are not equal, not if they are equal. If they are not equal, then add the next position and the current position. If it's partial, here's where we need to do a few more stuff. We need to find the direction between the two nodes. We normalize it. We need to find the distance, okay, between the two nodes. We take our direction and we multiply it by the distance, subdivided by 2, so that gives us half point. Half point between the two nodes will actually be the part of the window. We can add on the path position. To actually find the path position, of course, we need to take the direction and add it on the previous node wall position. We need to add a few bit up, so since you want him to pass through the window, of course you can change this to just this, and it will just make him go a bit higher. But we're going to connect all this with animations, so right now, okay, let's just see it. Okay, you see that the line passes from inside the window. But as I said, we're going to connect all this with animations and all that. So yeah, right now it's just a visual cue anyway. And we need to add on our wall positions. We need to pass the next position. We need to pass the actual path position we have over here, and we also need to pass the previous position. Okay, the order that these are added into the list are important. Otherwise, it was going to move on the next node and then to forward the previous node, and it's going to be a mess. If it's a connection of block, we're going to see it on a later video, which pretty much this says if it's a wall. We store the current direction to be what we have on the next direction, and on our wall path position we add the sort path. We also have this function to find the actual direction. Okay, similar, it's exactly the same like the one we have on the Pathfinder, but the Pathfinder is a whole different script and works differently, so I just copy paste it over here. And I think pretty much we have covered most of the stuff. Since we changed the wall position path from the sort path, we also need to go into the player interactions on our lane inside our visual path, visualized path. On our line set vertex count, we need to pass, instead of the sort path, we need to pass the world position path. Same for our integer over here, for our for loop over here, world position path, and the line position, we're taking them from the world position path. And of course, if active unit world path position count is greater than 0, then we enable the move indicator and we pass it on the world position path, on the final entry we have on our world position path over here. Okay, this is how we find it. And when we are clearing, before we populate our path for the active unit, when we are clearing the list, instead of the sort path, do the world position path. And I have another bookmark over here which we already saw. So this pretty much covers everything I want to cover at this part for the pathfinding. And of course we're going to fix a few stuff, because if I hit play right now and move around, it's going to give me an error, so I'm not moving. I have to wait to load all that. We're going to fix everything else with menus and all that. Okay, so you can select it from menus if you want to have the level creator or level editor and all that. Now, as I said, we're going to think about a bit what we want to do with the multiple floors and the pathfinding. And we also want to know, going to use animations when we are passing from inside walls and all that. Of course, there's no colliders to block if somebody wants to shoot, so he actually shoots from in here, because we have to look for walls, we have to look for windows, and all that are stuff that we can keep in mind when we are making the AI and all stuff. So there is a lot of meat in this project yet, and we can move through walls, not through walls, through doors. If we were moving through walls, would be a problem. Now, as I said, there is a problem with this that shows the entire renderers. That's why, because we're just taking the closest nodes, we are not doing any pathfinding for this. We're going to do pathfinding for each one of these nodes, and since we have threading, it's not going to take the whole thing into a hold. And we'll also be using it, since we only have to calculate for once for every character. Okay, so we're going to do a lot of cool stuff with this. So I'm going to end the video over here, and on the next part we're going to work again with the pathfinding. So you know what to do: subscribe, like, support me on Patreon if you're not, if you don't support me, and of course Patrons get to see the videos much earlier than everyone else, pretty much around a month earlier, and depending on my schedule, I usually sometimes I upload new videos even every day, and of course they all are on Patreon. And another way to support me is with grabbing a project or two from Gumroad, and we can keep making all this cool stuff for as long as we can. So I'll see you next time.